Welcome all to the finals of the software design competition. What an extraordinary point along the journey. We started with 68 teams just a few short days ago, and tonight we're going to see the top 6 finalists for software design.
Sign language is a language that uses visually transmitted sign patterns such as manual communication, body language and gestures. One sign can combine handshakes, orientation and movement of the hands, arms or body and facial expressions. Just like in spoken languages, there is no universal language, so sign language differs between most countries. There are currently millions of people using sign language in Europe and America and even more worldwide. Despite the large user base, sign language remains one of the most difficult languages to learn. Almost 90% of all deaf people have parents that can hear. Still almost no one has understanding what it means to be deaf. Let's take a quiz. Ready? True or false? Deaf people live in a silent world. Having a deaf child is a tragedy. All deaf people would like to be cured. Sign language can be translated with the translation system. Answer to every statement is false. Now, let's take a look at few issues about learning sign language. First, let's think about writing it down for later use. How would you write down something like this? There is no established system of writing down sign language. Although some optional methods do exist, they are not very well suited for the lexicon of sign language. Then what about learning all the new signs? How would you study something like this? It's quite difficult to read and understand all the different markings. Not to mention the natural learning obstacles compared to language learning during childhood. Adults have more trouble in remembering all the signs. Where would you start looking for the signs you want to learn? Books? VHSs? Online video dictionaries would be the best way to go if they weren't closed and so constricted.
Since we are trying to add in the home-oriented experience to our applications, that's why you can see every family member has their own account. So now I will just log in as Mike Anderson. So as one of the key features is to allow users to click on any recipes, view on the general details, ingredient list, preparation methods, and even nutritional facts. But this is not all about Project Apple. Our goal is to simplify meal planning while considering people with different lifestyle, eating preferences, and even medical conditions. So one example would be when we visit a doctor, we tend to ask them what we should eat and what we shouldn't eat. So with Project Apple, we made it simple. So the user can just click on the ingredients, go to the medical conditions, and in this case, I'm suffering from common cold. So a list of ingredients will be suggested to you right away. The users can further read about the dietary guidelines on common cold to know more about what they are dealing with.
One of which detects eye movement, jaw muscle contractions, as well as alpha and beta brain waves. Our biggest challenge.
He uses his eye movement and jaw muscle contractions that are detected in 2 steps to control the application. Each of his actions is mapped to a corresponding column. His eye movement is mapped to a first column, his weak jaw muscle contraction is mapped to a second column, and his strong jaw muscle contraction is mapped to a third column. There are 2 rows, and 1 row is constantly highlighted. The highlight changes alters between the rows on the exact time interval that is defined in the configuration application file. When one makes a valid gesture, it activates a cell in the corresponding column of currently highlighted row. If in that cell there are 2 or more menu items, they are distributed into other cells so he can choose which one he wanted to activate. Now we will begin with our speech feature. This feature enables the users to communicate with their surroundings. This is the text input menu where one can select characters to be spoken. When he selects a character, it is added to the text box under the status bar. By using our text input solution, one can select any character by using only two actions. One for selecting a group of six letters, and one for selecting the letter he wanted. Now, one will use speak function to activate speech model to synthesize the entire text.
Hello.
As you can hear, speech synthesis is possible. This is good for communication of handicapped people.
Every time I speak into the microphone, I feel we show my spoken words on the screen next to my face with sign language animation. If you are a hearing impaired student, you cannot hear my voice, but you can see it. With this approach, a teacher doesn't have to know sign language and no interpreter is needed. And I feel also supports more than one speaker.
This sounds interesting, but will it work in practice?
Volunteers at the Thai Association for the Deaf have used iFeel, and they think that with this software they could follow a spoken lecture.
What about higher education? Can iFeel recognize and translate the vocabulary used in advanced courses?
iFeel uses American Sign Language, which is used at Gallaudet University for the deaf. iFeel spells out words that don't have a sign. And the user can also add words to the dictionary for special terminology. Just add new words are added to spoken English. So that's all for our writing.